Greetings, mathematicians. Today our warm-up is a dot talk. Your job is to calculate how many dots there are without counting them one by one. Again, using your hand signals to signal how many different ways you can find it and being ready to explain how you see them. Teachers press pause while students think and then record the answers. Our learning target for today is I can identify inequality symbols and read inequalities from left to right. So we're going to talk about inequalities today. So we're going to build on what we've been learning. We're going to incorporate addition, subtraction, multiplication, and division operators into equations and inequalities today. So we're going to still use our strategies to accurately calculate facts, because remember that's key to everything we do in algebra. So using the songs, decomposing, memorization, whatever you use to help you get accurate facts. The first vocabulary word we're going to talk about today is equation. Look at that. What word do you see or hear in equation? Teachers pause and ask students for some ideas. An equation is a mathematical sentence. It must have an equal sign to be an equation, and both sides have to be the same value. And it can be solved for a number value. Because both sides have the same value, we can actually solve for the value. So if we look at all these examples, we see that they all have an equal sign. So they're all different equations. So when I think of an equation, I like to think of a balance. Like maybe you use in science class a balance that both sides have to be equal. They don't have to have the same number of terms or anything like that, but the values on each side must be balanced. So if I take 3 times 2, I'm going to get 6. And I look at the other side, I have 9 minus 3. I'm also going to get 6. Because those two values are equal or equivalent, we say this is a balanced equation, and it is a true equation. Okay, so a variable is our next algebra vocabulary word. So I want you to listen to that word, variable. Talk to the elbow partner about what do you think a variable means and what word do you hear in there. Think back to the Math Antics video. A variable represents a value that can change, and it's usually represented by a letter like X, Y, A, or B in math class. Okay, so all of these are still equations because they have equal signs, but they also have red variables. They have letters that are standing in place of a number. Because they're equations, we could solve for the variable, but we're not going to do that right now. We're just going to talk about the vocabulary word. The next word is substitution. Think about if you play sports, sometimes you have a substitution and someone substitutes in for you, or when your teacher's sick, you might have a substitute teacher. In math, substitution is similar. You're putting a number value in to replace the variable. So when your teacher's sick, we put another teacher in to replace them. Okay? So if we look at A plus B, when A is equal to 6 and B is equal to 4, we could substitute the 6 because it tells us the value of it that is 6, so 6 plus 4, and then we could calculate it and get our total of 10. So we can substitute variables in if we know their values. Our next word is inequality. So I hear the word equality in there again, or equal, but now it has an in prefix in front of it. So what inequality means, that it's a relationship that is not equal. It does not have an equal sign, and each side of the relationship is going to have a different value. Some inequalities could have multiple solutions. There might be more than one right answer. So here are our inequalities. We've got our greater than sign. Look at which way it's open to the left. Our greater than or equal to sign. Again, it looks like a greater than sign, but now it has an extra line underneath. That's that equal to part or equal to part. Then we have a less than and a less than or equal to sign. And then finally, if it's an inequality, we would use a not equal sign, or an equal sign that has a line, a diagonal line through it, kind of like a no parking, means not. Okay, so these are the signs that we're going to be using for inequalities, and it's super important. We usually can draw them correctly, but it's important that we also read them correctly, and that's what we're going to practice today. Okay, so let's look at this first example here. We have 1 plus 4 is something to 6. We have to choose the inequality symbol that goes in it. Well, to do that, we have to evaluate both sides. 4 plus 1 is 5, and this is 6. So I know that I want to be open to the 6 side, but then I read this from left to right. I'd say 1 plus 4 is less than 6. Okay? My symbol would be the less than sign because the value that we run into first when we're going left to right is smaller. So 1 plus 4 is less than 6. Now we're going to look at this next one. Now we have 18 divided by 2. We have to choose the inequality that goes in there when we're comparing it to 7. So again, I have to evaluate 18 divided by 2. I know that's 9, and I have 7. So I'm going to read again from left to right. So 18 divided by 2 is greater than 7, is how I would read that. So again, first I have to figure out, or I have to evaluate both sides until I get one value for each of them, and then I can compare those values using an inequality symbol. Okay? So now we can look at this one. I'm going to put this symbol in it. How would we read that? Go ahead and read it to your elbow partner. Again, we always have to read left to right. So we would say 5 is not equal to 3 minus 2, because if we solved that, that would be 1. And we definitely agree 1 is not equal to 5. So remember, we're going to do the equal sign with that not line through it to show no, they're not equal. So now we're going to follow the directions. Read the statement. So first we're going to read it from left to right, and then we're going to have to determine a value. What number could we plug in there that would make the statement true? Okay, so first I'm going to have the person on the left-hand side of the two partners read the statement out loud. Go ahead and read this one to your partner. And now talk about what value, the person on the other side, what value could you plug in there to make it true? Teachers pause while students share. So if we read this, it would say A is greater than 25. So I'm going to find 25 on my number line, or on my number chart. And it says greater than. It doesn't say equal to, so it can't be 25. That's not one of the answers, but it could be any number that would be greater than 25. Okay, it could be any number on here. It could be a million. It could be a billion. As long as the value is greater than, it could be 26, 27, 28, 100, a million, and so on. As long as the value A is greater than 25, that would make this inequality true. Here's our next inequality. The other person read this one, again, left to right. How would we say that? And the partner, you're going to come up with a value. What could C be to make this equation true? Go ahead and discuss it. Teachers pause. So if I read this one, I would say C is less than, because the smaller side is pointing to it, 25. So could it be 25? Is 25 less than 25? No, 25 is equal to 25. So it could be 24, or it could be any of the numbers that would be less. So 24, 23, 22, all the way down to 1. It could be 0. It could be negative numbers as well. Okay? Our next one. W, I want you to read that statement to your partner, and then on the other person, I want you to tell me what would you color in on the number chart that would make this equation true. Hopefully you said W is equal to 42, or you could say equivalent to 42. They have the same value. So what number could I plug in for W? This one's a little trickier. There's only one value that would be equivalent to 42. It would be 42. Okay? If we were just talking about one number, we could have done an expression as well. Okay, the other partner, read the next one to your partner, and then figure out what value could you use for W to make this statement true. So now this one says W is not equal to 42. So this one's kind of the opposite. So 42 cannot be the answer. It could be any other number on the number line. It could be greater than 42. It could be less than 42. The only thing that it tells us is it cannot be equal to 42. So the only number that we could not choose would be 42. So any other number, 43, 13, 94, 100, a million, would all work as long as it's not 42, because 42 is equal to 42. Okay, the other partner, read this inequality, and then the elbow partner, give me an example that would make this statement true. What value could I substitute for x? Okay, so my first job is going to be, I'm talking about 50. So I'm going to say x is greater than or equal to. Now I've got that extra part underneath. So this means greater than or equal to 50. So I'm going to think about 50. What that count? Would 50 be greater than or equal to 50? Yes, it would be equal to 50. And then to fulfill the other parts, it also could be any number greater than 50. So it could be 51 all the way up to 100, up to a million, up to a billion, or infinity. Okay. Our next one, the other partner, read this inequality again from left to right, and then come up with a solution you could use. What could we substitute for y to make this true? Okay. If I look at this, now I have y is less than or equal to 50. So again, I need to find 50 on here. If it has the equal to, it does say equal to, so I can count 50, because 50 is equal to 50. And then anything else that I could choose that would be less than. So any numbers in my 40s, 30s, 20s, teens, all the way down to 0 or negative numbers would be true in this equation. You could have chosen any of those. Okay. So I want you to look at the inequalities at the board, and I want you to each share, you and your elbow partner, one thing that either you discovered or that you're like, oh, I understand that better than I did before. So go ahead, teachers, pause, and students share. So our learning target was, could you recognize the symbols and can you read inequalities? So look through this list. Are there any of them that are still tricky for you that you need to make sure that you work on, or that you need to maybe write down so that you make sure that you get them straight in your head? Because we are going to continue to use these tomorrow to do one more step with them. So if we go back to our learning target, I can identify inequality symbols and read inequalities from left to right. Tell your teacher with your fingers, are you at a 1, 2, 3, 4, 5? Again, this was our first day doing it, so you might be like at a 2 or a 3 still. If you're feeling pretty comfortable and confident, maybe you're at a 4. If you're at a 5, then maybe I'll have you come up tomorrow and teach the next part of the lesson.